When a metal X is treated with sodium hydroxide, we should note down such questions. When a metal X is treated with sodium hydroxide. Now please note this is a metal. A white precipitate A is obtained. A white precipitate A is obtained, which is soluble in excess NaOH. Wow. Excess NaOH, this dissolves, giving an aqueous solution B. And there is a complex. Well, B is a complex. How lovely. And since excess NaOH is giving it, it should be preferably a hydroxo complex. Compound A is soluble in dilute HCl to form a compound C. Now, if I add dilute HCl, it becomes soluble to form a compound C, which must be an aqueous solution, of course. A, when heated strongly, gives D, okay, which is used to extract the metal. You heat strongly, you get D, which is used for extraction of metal. Identify X and ABCD, write suitable equations to support their identities. Can we do that? Of course we can do. Extract metal. Now first of all, you see, the most signature hint in the entire question is this. You have a metal which dissolves in NaOH. Now metals normally do not react with NaOH at all. If you take things like iron, they have no reaction with, in general, any NaOH or a base. Which metals can react with NaOH? Amphoteric metals like aluminium, tin, lead, these are the metals. Now, this dissolves in NaOH, it gives you a white precipitate, yeah, it rather reacts with NaOH to give a white precipitate, fine, which is soluble in excess. Again, a hint of amphoteric nature. This precipitate, it must be a hydroxide precipitate, and this precipitate dissolves in NaOH, fancy. It also dissolves in HCl, which is again very beautiful and very, very good. Great. I have a hydroxide which is white, which is amphoteric in nature. I am also told that it is soluble in dilute HCl. Now all this hints towards aluminium. Why? Just write aluminium and see. Now, in these kinds of word problems, one idea is required, and the moment you get amphoteric nature, hydroxide dissolving in NaOH, forming hydroxo complex, this dissolving in HCl, this classically and typically looks like a +2 or +3 oxide. Why not +4? A +4 oxide will have a problem because if you take things like PbO2 and SnO2, they would find it difficult to dissolve in HCl directly without a redox reaction. But aluminium can dissolve very beautifully, so we eliminate those nonsensical options and we get aluminium as a potential candidate. Let me try this out. Say if X is equal to aluminium, this would become, A becomes aluminium hydroxide, B becomes NaAlOH whole 4. What is the reaction? This is a very easy reaction, yes. AlOH whole thrice on drying will give you Al2O3 plus H2. Water vapor will evaporate and I just get this. Makes sense. AlOH whole thrice plus 3HCl will give me AlCl3 plus 3H2. So yes, I have that reaction also, no problem. And Al2O3, molten alumina, is dissolved in cryolite and electrolyzed to obtain metallic aluminium. That also, my dears, is a very true reaction. And how would aluminium react to give you aluminium hydroxide? Aluminium plus NaOH. Apparently, this is alkaline medium plus H2O. Now, this is giving me AlOH whole thrice plus 3/2 H2. I have written this reaction for the sake of writing it. It is my duty to inform you that the lovely NCERT has framed this wrong question. No metal will give you metal hydroxide on treating with NaOH. As a matter of fact, if aluminium and NaOH react, it directly gives you this complex. You get hydrogen and the complex directly. You don't first see metallic aluminum turning white, giving you aluminum hydroxide. That's a very wrong idea. But it is legendary and celebrated NCERT. They are free to change even God's creation, and they manipulate chemistry like anything. So I have presented a solution which is commonly given in guides, and I cannot, as a student of chemistry, I cannot help getting irritated that it is a blasphemy. I mean, what they have done is sheer nonsense. I have written a reaction. And I have just mentioned it at the end with great frustration. Let me point out, this is not the correct reaction. This aluminium plus water giving aluminum hydroxide plus hydrogen. No, they are dissolving this in NaOH. Please note, there is no NaOH required here. As a matter of fact, is this reaction impossible? Such a reaction is possible if you take aluminium amalgam and add water. It is possible. They have not done that. They have added NaOH. If you add NaOH, you will never obtain white gelatinous precipitate. Doesn't happen. It just doesn't happen. A solid water insoluble aluminium would never give you with NaOH aluminium hydroxide. It would directly give you this complex. But again, NCERT is not about logic. It is not about chemistry. It is about the ego of the people who wrote it. So there we have it. This is the Bible. Take it and feel happy. Let me go ahead.